All right, welcome everybody to the third and final part of this webinar series on moving from notebook hell to container heaven. So I'm still Chris Peters, I'm the CEO of DataMinded, and I still have with me Pierre. Pierre, can you also say a quick hi to the people?
Yes, welcome back everyone. I'm Pierre, data engineer at DataMinded. I'm mostly working on Datafile, which is our data platform.
Yeah, exactly. So, well, let's dive straight in because we only have 30 minutes. We try to keep this short and brief. As usual, if you have questions, you can put them in the chat and we can answer them at the end, right? Today is the 25th. We're going to talk about orchestrating your containerized data pipelines. So maybe if you go to the next slide, yeah. So indeed, this is the third part. After this, there will be a hackathon. We plan to do the hackathon here in the office. That would be super cool, but unfortunately, I don't think it's very responsible to do it with Corona now, so we're going to do it virtual. But the idea is the same. Like we took you from a notebook to a container, and then from the container to the cloud, and now we're going to see how to orchestrate all of that, all these three steps. We're gonna guide you through that in the hackathon, so you can do it yourself. That's the idea. You can find the link on datamind.be/webinars. You can find more information. So why are we doing this in the end? If you look at any machine learning project, the actual machine learning code, writing the model, is a very, very thin slice of your work, right? There's a paper by Google explaining just that and explaining also about all the technical depth that you have in a typical machine learning system, because typically they hire 10 data scientists that all know how to write ML code, but they don't hire enough engineers to do all the other things. So, and then you end up with a high technical depth. If we zoom into that process a little bit, from a very high level still, if you think about the value stream to get to a machine learning model in production, you always start with some, and this is super high level, right? This is a bit an abstraction of the MLOps levels that are described by Google as well. You start with data, raw data coming in, then you do some development in Python or Spark or TBT or whatever, or in Julia, whatever you use for development. If that's done, what you deliver is code, right? That code has to pass through some kind of CI/CD pipeline. And that, as we saw, like ideally, we believe that containers are a great artifact as an end result of your CI/CD pipeline. And then you run your code in production. So those are the three big steps in your value stream, from raw data actually to some kind of impact you want to create. If we zoom in a little bit on that, well, in the development step, what you do, typically you start with some data exploration, some experimentation. And then if you see like, yeah, I have a model that works, maybe in my notebook, now it's time to industrialize that. That's what we saw a lot in the first webinar. So how can I get from an experiment to an industrialized version of my code? Then the second step is the CI/CD process is typically a bit more boring, I would say, because you have to take that code, you have to build it, test it, package it, and deploy it. But that's, in the end, that code needs to run somewhere, and that's what we saw in the second webinar, right? Where you take your code and you make sure it ends up in a container that can be deployed somewhere, right? And then if you have your container, it typically runs in production. So you have a typical production pipeline for machine learning is that you do data ingestion, you do some data prep, you do some model training, then you evaluate your model, and then you infer, based on new data coming in, you infer the predictions based on the trained model, right? So this is very high level what it's about, what we're going to focus on in this webinar. So all these steps, Pierre will guide you through this. And I hope in the context of this MLOps thingy, it makes sense of where we are here, right? So if you want to do MLOps, if you want to industrialize your machine learning, I think you should work on all these three pipelines. You should have a good development pipeline. You should have a good CI/CD pipeline. You should also have a good production pipeline. And that production pipeline, that is something where Pierre will zoom in today.
Thanks, Chris, for the intro. So what I would like to do, like I did last time, is a quick recap from parts 1 and 2. Just if people didn't get a chance to watch them, you can rewatch them in our webpage, dataminded/webinars. So what we did is we looked at the Titanic use case, which we started from a notebook, and without going to the details here, what we did is look at the list of passengers and try to do a predictor for survival of those passengers. And this came from a Kaggle notebook, quite a famous one, and we did a stripped down version of it just to have a story to tell. In practice, what it looks like is we have a training set, which is the list of passenger and whether or not they survive or not. We extract some features and some target from that. We train a classifier, and then we apply that to a new list of passengers to predict if they are likely to have survived or not. Excuse me. So what we did in the first part is take a notebook, extract that code to some properly organized code and test, write a Docker file, produce a Docker image, and run it locally on our machine. And then in the second part of the webinar, we also did the exact same thing, but we ran it in the cloud using AWS Fargate. So that's what we did. And in part 2, we also explained a bit how to build the necessary infrastructure to do that. So that's where we left things in part 1 and 2. And you can find the code for that on GitHub in that, on that link. So a bit more in details, what we had, the ingredients for part 1 and 2 were first a Docker file, where this is a recipe to explain how we're going to build your image and run your container. Then we ran this on our machine using a Docker build command. Then we Docker run that image as a container, and we did that locally. So that's part 1. We did everything from building, storing the image, and running it on our machine. And then in part 2, what we did is the same thing, but running on Fargate. So we still built locally the Docker image on our machine. We pushed that image to a container registry, which in this case was AWS ECR to store the image. Then we actually ran the container on AWS Fargate, which is one of the, like we explained last time, one of the many options to run your containers. And then finally, we were able to look at the logs in CloudWatch and look at the results in S3. And of course, we had to go quite fast in the webinar. So in order for that to work, we had a lot of infrastructure work to do, and we used Terraform to do that. So today, what are we looking to do? Starting from there, we will take the code from part 1. We will split it in more granular steps in a data pipeline. Then we will still produce some Docker images. After all, it's about containers. And then we will orchestrate this with Amazon Managed Airflow called MWAA. And then this is still running behind the scenes, running the containers on AWS Fargate. So most of the ingredients you're already familiar with, but we will introduce a few new pieces. So like I said, we're going to split the job in a pipeline. We're going to look at what orchestrator exists in the cloud, and then we're going to actually use Managed Airflow to do that. So first thing to do is to split the use case as a pipeline. So if you remember, the job from part 1 was very much all-in-one job, in the sense that here's the main function. We were loading the data, cleaning the data, training a classifier, and then predicting. So everything happened in this one step: ingest, clean, train, predict, which was very nice for a one-step job. It's a bit like what Google describes as the MLOps Level 0. You're just responsible to train some model, deliver the model, and that's it. It's a one-off job. Now we would like to go a bit further than that. So let's make the use case a bit darker, if you allow me. So we'll take the same Titanic use case, but imagine that now we have the following scenario. There is a daily ship disaster. Every day we receive a list of passengers and their survival. And every day we will also receive a list of missing passengers. So we don't know if they survived or not, and we want to predict that. So this will look like that. So the same as before, but on a daily occurrence, just for the sake of the story here. So how do we go from a one-time job to a data pipeline, and why? So the shortcomings of the all-in-one job is that we're not able to reprocess data from the past because it's just a one-off. It's very much, like I said, a black box. So we do everything in one box. So if anything goes wrong, it's hard there's no intermediate data to look at what went wrong and to debug. That also means we cannot reuse that partial data from the different steps for other purposes, which might be useful in the context of a company. And we cannot also do prediction batch and on demand. So on demand would be, I have a model, I want to serve that model, and people can interactively ask the model to do predictions. So what we aim to achieve is to run the pipeline, the prediction as a pipeline, get new data daily, store all the intermediate data somewhere at each step, get new predictions daily, and also on demand. So let's work towards that now. But first, so let's recap what it means. So we have the training data that comes in daily. We ingest it, we put it in an S3. So that's a new step. Then we're going to clean the data and extract the features. Again, put that back on S3. And then train the classifier, save the model, save that on S3. Same thing for the test data, ingest it on S3, clean it, save it on S3. And then finally, we can do the prediction and save the outcome on S3. So it's really just the same code as before, but split in many different steps. And we can reuse the data at all points. We can version the data at each point based on the date and so on. And then finally, a nice benefit of that is that the classifier that we train, we can also save it in a system like SageMaker, where we can make the on-demand model serving. So SageMaker can do that, for instance. You can create an endpoint where you can interactively ask for predictions. So I'm not going to look at the code too much, but just to show you that it doesn't change much. The ingestion, we're just loading the raw data and writing it in the historical data lake on S3. So for that, we have some convenience functions to load and write CSV and Parquet files. Then we have the same cleaning and extraction feature as before, but that's just one step now, just about that, cleaning and extracting features. Then we have this code that is only about training the classifier and save it to S3 as a model. And then finally, the last point is the prediction, which is just loading the model from S3, receiving some new data and doing a prediction and saving that prediction to S3. So I hope the use case is clear. Now, that is very nice. We just split our code in all those different pieces. Now, how are we going to run all those different tasks in the right order and for the different dates? That's why we need to look at orchestrators. So let's quickly talk about what orchestrators are and why do we need them. So orchestrators are typically helping with the following. It's typically about defining workflows and preferably as code, even though you also have point and click kind of workflows editor. We prefer workflows as code. A workflow is typically composed of tasks. So it's a sequence of tasks. And those tasks typically have dependencies between those that you express as a graph, typically a DAG meaning directed acyclic graph. So it's a relation expressing all the relationships between your tasks. Typically, you want to schedule the execution of the task. Most often, it's time-based, for instance, daily, every hour, but it can also be trigger-based, execute that task when something happens somewhere. For instance, wait for a file to be in S3 to trigger the task. Another thing the orchestrator do is that they delegate the actual execution of the task to some runtime. So the orchestration is just about the dependency and the timing, but then when it comes to executing the task, you need a system to run it. It could be a local, it could be something like Yarn or Kubernetes, and you have many more options. Then finally, what you expect from an orchestrator is the ability to monitor the execution of all the tasks. Look at the logs, look at the metrics, look at the performance metrics, and so on. So you're really on top of what you're deploying and orchestrating. And then finally, a nice feature of most of them is to look at the history of tasks, because if you have a daily task, you want to see what happened over time, you want to look at the past, you want to see if maybe they start taking more time to execute over time, and so on and so on. And finally, also, you might want to be able to replay the past, because maybe some data was wrong 3 days ago and you want to rerun the job from 3 days ago. So that's also typically what they offer. And I'm not going to go more in details. There are many more features, but these are the typical things you expect from an orchestrator. That being said, the most famous one is probably Apache Airflow, at least in the data engineering community, is really the one that is mostly used. We see it everywhere. So what you see here is the graph I was talking about, the DAG. So that's where you express, so all the green boxes are tasks and you express dependencies between them. Then it offers a list of, you can have many of those DAGs. So you have a list of all those DAGs and you can see at a glance when it's run, what is successful, and so on. Then you can also have this view, which is the historical view I was mentioning. You can see each line now is one task, and you can see in the past if they were executed correctly or not. You can see the logs for a given day. And then finally, you can also look at metrics like how much time does each task take on a daily basis to run, so you can see if there's a trend and if you need to do something about that. So yeah, that's Apache Airflow. Like I said, it's the most popular one. You define your DAGs as code in Python, which we like. You can see the history of tasks, you can see the logs and metrics, you can replay the past jobs. And also it's such a big project that you have a vast library of predefined operators and plugins. So each task can do many different things. You can integrate with many systems, and for that they offer core plugins and community plugins. So really, it's hard to find a use case you cannot cover with Airflow. It's not perfect, but it's really quite complete by now. So I should mention that Airflow is not the only player on that scene. Actually, far from it. Another one that we see rising in popularity is Prefect. I haven't used it personally, so all I did here is copy some screenshots from their website. It looks similar to Airflow, and I expect to find the same features. If you want more details, I invite you to look at their website, but they're really rising in popularity. And then, like with everything in IT, Apache Airflow and Prefect are only two amongst like a really big space of orchestrators. So here's Google Workflows, you have Daxter, you have Argo, you have Luigi, even though it's a bit old now, that's from Spotify. You have many players there. But then again, we only see those two players at our customers mostly. Now, here's an intimidating diagram. I need to talk about manage Airflow on Amazon, which is what we will use today. But don't worry about this picture. That's the picture they give on their website. It's a bit scary. So let's look at a simplified view of that. What is manage Airflow? Well, it's what you expect. It's really, you don't have to deploy Airflow itself because it's quite complex, as the previous picture was showing. You just create a managed environment in Airflow, and basically you can think of it as a user. You just have an Airflow ready for you to work. The full story is a bit more complex because, for instance, to look at your logs, well, it reuses everything from Amazon, of course. So your logs are going to be in CloudWatch, your DAGs are going to be in S3. The scheduling happens through SQS, and your Docker images will be in what we used, ECR, to put your images. And of course, there's some secret management in KMS. So typical Amazon fashion, they have a managed service and they reuse all their other services to do all the pieces of the infra. So with that in mind, this is what it looks like in the end. When you deploy it, you just have a normal Airflow, but you can see the URL is something in Amazon. So I just provisioned this, and now I have my Airflow ready, which is already showing the DAG that we will be building together. So, and that's very important. Each of those tasks, like I said, need to run somewhere. In this example today, we're going to run them in Fargate. And for that, we use the ECS operator, which is a community provided operator. So each of those boxes will run a Docker container on Fargate, just like we did last week. So that's an extension of our work from last week, from 2 weeks ago. So like I said, we're going to use Airflow, Fargate to run the Airflow task. And of course, we're going to have to set up some permissions in IAM for that to work. So it's time to get hands done. I'm checking the time quickly. Yes, we have 10 minutes left. So like I did last time, just for the sake of time, I set up already a lot of infrastructure beforehand, just so that it's smooth to show you what it looks like. So let me switch to my other window. So what did I do? First, in ECR, like last time, I created a repository where I can push my containers, and exactly the same as last time. So in the terminal, we do a Docker build, a Docker push to ECR, and now the image is here with all our code. By the way, I'm reusing the same Docker image for all the tasks in the pipeline. We will just call them with different arguments to perform the different tasks. Then we can see that for Airflow to work, we need to provide a DAG, and you need to put that DAG somewhere, and that is S3. So we have a bucket here that we called Airflow, and we have a DAX folder, and we have the DAG file here, which I will show in a minute. So that's how Manage Airflow will be able to pick my DAG and display and run it. So now the most important part of today is MWAA. So I created a Titanic demo environment. And if you open the Airflow UI, that's exactly the view I just showed you. So you can see I already put my DAG here. And that looks like this, which is familiar. It's how we split our code in all those different steps. And then finally, each of those tasks will actually run. So if I enable that to run now, the scheduler will automatically see, okay, I have those tasks to run. And so it will start scheduling those. And I don't know if I should probably ask it to start. Yes. And then what it will do is schedule each of those tasks on ECS. So you see now, for instance, the two first tasks are running. And if they're running, if I go to ECS, I still have my cluster from last time. So the cluster is ready to receive tasks, and we can see now that we have tasks being scheduled. So Airflow is calling ECS to create those tasks on Fargate. This will take a bit of time, so I don't know if I have time to wait for that, but in the end, what this will do is execute all of this in the right order. So the whole point of defining a DAG is that it knows this needs to run before this, and all those needs to run before I can go to the predict stage. So if we were to wait long enough, all of this would hopefully become successful, and we could look at the output data on S3. Hopefully I can already show you that. So on S3, I have this folder with my test and training data. And if I refresh this, now you can see I have a raw folder. That's the output of my ingestion. So, and for each date, I ingest the data, and now I can see some data appearing here. Next, if we were to wait long enough, we would see the features folder, and then the model folder, and then the output folder. So each step in this DAG is going to produce some files and put them on S3, like we said. So yeah, you can see the first task has succeeded. So now it knows it can go to the next step. So maybe let's have a look quickly at the DAG. So a nice thing about Airflow is you can actually see the DAG as code here in the UI. So for those who've never seen this, you use a Python dialect to define a DAG, and then you create some tasks, like here, all the tasks are created, and then you use those little symbols to define dependencies. So you say this depends on this, and so on. And that's how you end up with the graph I just showed. One interesting thing to note is that each of those tasks can be anything. In our case, there are, like I said, ECS tasks to run on Fargate. So I have this get task function I created here. What do we do here? We use the ECS operator. We say on which cluster we want to run. We say we want to use Fargate. And then we have some configuration, but basically that's the equivalent of what we did in the last webinar, where we configure something to run on ECS. So Airflow is doing that now for each of the steps. So if I look back now at the graph view, we are a bit further in the execution. So now, for instance, the clean training has finished. So if I go to S3 and I refresh, I will see some features for the training being produced here. So like I said, every step is going to produce some data. Now it's doing the final steps, almost final steps, and you get the ID, I hope. So that's a bit how we did everything, from a local notebook to finally orchestrating online. I realize this is going really fast. Again, you can look at the code in the repo to see all the details, and I have a bit more to say. So those are backup slides, everything I just showed you. This is the DAG I just showed you with the task operator. And then, yes, one thing I forgot to mention is how every time I modify my DAG locally, I need to do AWS S3 copy of my DAG to this folder so that Airflow will pick it up again, right? And then finally, this is what I showed you about executing on Fargate. And in the end, yes, that's important. I should show that. So if I take any of those tasks, I can always look at the logs, because Manage Airflow will collect the logs from CloudWatch and put them back here. So those are my logs. You have a lot of noise from Airflow, but then these are the actual logs from the task running on ECS. Those went to CloudWatch and were collected back here. Now, that was not the whole story. That's the same message as last time. I won't bore you with the details, but we had a lot of setup to show you this. So we use Terraform to do infrastructure as code. I don't go into the details. The message here is that we had quite a bit of work to do, more than 35 Terraform resources to create. If you're interested in the details, here's the link to the whole infrastructure. So yes, it's a managed service, but it's not that simple to get to the simple state I showed you. Which leads me nicely to the summary. So what did we have to do? We had to provision the infrastructure, build and publish an image to ECR, create task definition in ECS, write an Airflow DAG, leveraging the ECS operator, upload our DAG to S3, and finally execute it, check the logs directly in Airflow, and check the output on S3. And I cannot finish this without doing what I always do. So Datafile is the platform we build at DataMinded. Why I want to talk about this again, because we have those nice commands, Datafile project build and Datafile project deploy. And when you run them, you get exactly the same result we had today, but with only 2 commands and none of the infrastructure provisioning. So here I have a screenshot of the environment, and I hope I have time to show it after. Basically, you see the same DAG in a managed airflow by Datafile, so none of the setup. And if you look, you can also have the logs collected for each of those tasks. And so the message here is that with 2 simple commands, Datafile does everything we did today. So all the provisioning of ECR, building the image, publishing it, creating all the secrets, provisioning an airflow, doing local validation of your DAG, running your containers on a managed Kubernetes cluster, and so on and so on and so on. So maybe quickly, let me show you that because it's better in person. So this is Datafile. So I don't think I explained, but we have environments. So each environment has an Airflow environment that comes with it. Here you can see my project here. I can see the exact same DAG I deployed on Amazon, but this is completely managed by Datafile. And then I can see the task execution. I can take any of those, look at the logs, look at the metrics. You can define several projects and run several projects in different environments. We have notebooks too. So basically everything I explained over the last 3 webinars, we capture in a product called Datafile, and it makes things really easier. And of course, you don't have to take my word for it, but personally, having to build these demos for those webinars, I realized how much easier it was to do with Datafile than using existing services.
And maybe to add to that, Pierre, so thanks for the demo. We sometimes have the discussion with clients like, yeah, but we can build this ourselves, like just what Pierre did now. And so the answer is yes, you can even just take the repo that we just published and start from there. And you'll do fine for a few projects, right? It's only when you do this at scale, you have multiple teams, you have multiple environments, multiple airflows that you need to run, multiple network setups what we typically see that teams start to slow down a lot, spend a lot of time in infrastructure. And there, I think it shouldn't be your core business, right? It should be your core business to build the data pipelines, to build the models. It should not be your core business to manage the entire value chain from left to right. So, and that's what we want to speed up a lot. So remember, from where I explained from development to CI/CD to production, that's the entire value chain that we want to speed up a lot with Datafile. So if you're interested in learning more about that, if you want to see a demo, if you want to play with it yourself, definitely feel free to contact us or go to www.datafile.cloud. And then you can also register there if you'd like. All right, let's look at questions. I think, Pierre, that's no, sorry, you still had a what's next?
No, yeah, we already explained in introduction, so we're gonna have a hackathon. Please go to this link if you're interested and register. I think it will be exciting. Again, what we will do there, give you hands-on experience with Docker, build your completely containerized data application, and deploy and orchestrate it in the cloud. So, okay, sign up.
Cool. All right. Yeah, I hope to see a lot of people in the hackathon. Unfortunately, we cannot do it physically like here. It would be cool to do it here in Leuven, but yeah, it's in the current conditions, it's not responsible to bring as many people together, right? But so let's do it online and let's have fun. There are a few questions coming up in the chat. Christophe asks, does Datafile only work on AWS or also on other cloud platforms? So the answer today is only AWS, but we do have the ambition to have an Azure version very soon, and later in the pipeline also a Google version. So because we build it quite cloud independent, it's just a matter of rewiring all the connections, if you will, to making sure that it can run everywhere, but it should be able to run everywhere. And when I say everywhere, I mean everywhere where we can run Kubernetes, ideally in a cloud environment. So if it's more, can you run on-prem? We're not saying no, but the team is a little bit more skeptical to on-prem situations. Today, our clients use it on AWS. Then Julien asks, like, do these orchestrators specifically optimize computation time by parallelizing tasks? Or do you recommend to also use libraries like Dask for multi-threading and parallel processing?
I can take that if you want.
Okay. Go for it.
So orchestrators, at least the ones like Airflow, are not dealing with data. So they're just about the orchestration. There's about saying I have task A, B, C in that order, and that's it. Each task then will actually run somewhere. Like I said, here we used a Python job running in a container. You could use Spark, you could use Dask. So the actual runtime and performance of that is up to you, where you deploy it and how you write your code. The orchestrator is not concerned with that. It will report on the execution time for you to see, but it's not doing anything about that. Some orchestrators, which I didn't touch on today, take a different approach where they actually do also the data processing, but most of what we see is using Airflow Prefect to use generic orchestrator.
Yeah, maybe to add to that, so indeed in Airflow you can have different tasks in parallel, and they will run in parallel, but as Pierre said, it will depend on what your underlying mechanism is. So if you just schedule 2 Fargate containers in parallel, they will run in parallel. The same if you schedule it on a Kubernetes cluster. But for instance, if you have one EMR cluster and you schedule those 2 tasks in parallel, in EMR, the default is that the tasks on the same EMR cluster are processed sequentially, right? So you're still, even though Airflow says, yeah, I'm running both tasks, yeah, well, actually EMR is only running one of the 2 and put the other one on hold. Yeah.
That's actually all configurable. So in Airflow, you can say, and we've seen that, right? I've shown that several tasks were running at the same time, and you can define all of that in Airflow. How many concurrent tasks should run at the same time? So it will try to run as much as possible within the bounds of your parameters. But like Chris said, the underlying architecture, it depends. Here in Fargate, we can do as much as we want in parallel. We just pay for it, right? But if you have a cluster with a queue, then Airflow will just send the task to the queue, and you're limited by that.
Yeah, and maybe just to add one more thing to it, what is nice about Airflow is you can schedule, for instance, to run every day or every hour or whatever, and then if something goes wrong and you see like the pipeline hasn't run for a few days, or you found a bug and you need to rerun for the last 30 days, you can just clear your DAG, and then it's just sequential, like it schedules all the 30 days. And then again, you can say like schedule them day by day or schedule them all at once. And then it's super cool to see then all of a sudden you get a lot of containers being spun up and running all your tasks, and then bam, like an hour or 2 hours later, it's done. So that is nice about an Airflow or an orchestrator in general, that you have the general overview. If you just have a cron job, like every day at 2 a.m., you need to schedule this on Fargate, but then something crashed, but actually, how should we rerun this and all of that? Like that is nice in Airflow. You can just clear a DAG for the last 30 days and it will recompute automatically. It's pretty nice. Then Matthias asks, would you always recommend to use Airflow, or are there situations where you would recommend an alternative solution? Maybe I can give a shot at that. So if you only have like 1 or 2 steps, if you have very simple pipelines, then like Airflow doesn't add a lot of value. Also, if you have like these trigger-based pipelines, like for instance, I have a new message on the queue, and then I trigger a Lambda function, and then I post to another queue, like that trigger-based flow, you can do it in Airflow, but typically Airflow is better if you do batch, and you do batch at a schedule. That's where Airflow really shines. And then maybe also where Airflow is really good is you have multiple different technologies, like here is a Python job, here is a Spark job, here is this, here is that. If you do everything only in Python, maybe Prefect or Dexter, because they're very Python oriented, maybe there you can more closely integrate them with your code. Well, Airflow doesn't really know a lot about your code, right? Just trigger this Docker container with these parameters and whatever. Yeah, I would not use, maybe to also add that, there's a whole discussion about, for instance, in Azure, you have Azure Data Factory, which is good for ingestion. We use it for that, but in Azure Data Factory, you can also build pipelines and do all your orchestration there. I'm not saying you cannot be successful with that, but we haven't seen a lot of success with it. So I would not use Azure Data Factory for orchestration. There's also on the ThoughtWorks technology radar, they also recommend against that.
The fact that Airflow is code-driven, it's not just because we're coders, it's because it comes with all the benefits, right? You can version your file, you can collaborate on a DAG, you can see what happened. Whereas click and point tools, I do something, Chris does something, watch the latest version, what happened, watch the diff. It's a bit hard to look at.
Yeah, indeed. All right, then Brent has a question. So if you have a lot of jobs that have the same dependencies and you want to run them in parallel, then you would need to pull all these jobs in your DAG definition and have a separate Docker container for each job. Or you mentioned something about using the same Docker image for multiple jobs, but how does that work?
So I think there are several questions in there. Let's answer the last one first, so I can quickly show that. So if I look at the DAG again, so here we use a single Docker image, which is defining this task. The only thing that we change is the command. So here the command is different for every task. So here the command is ingest, here the command is ingest test, here the command is clean training. That's one pattern you can use. So I built a single Docker image, and then I can run that Docker image with a different command. And then my code, in my Python code, is accepting those commands and say, you want me to ingest, I'm going to run that. So that's one pattern. You can also have different images. That's really up to you. So I hope that answers the second part. First part, let me check. So a DAG, so in a DAG, so this is a single DAG, right? And here what we see, so we see that this depends on this and that. And so indeed, we are explicitly defining all the dependencies. Now, what we do often see is that we don't want to have a monster DAG with everything that runs in your company. So what you can do is put dependencies between DAGs. So imagine that the result of this prediction, someone needs it for another project. Then what they can do in Airflow is build another project, another DAG, and have the first task of that DAG will be wait for that prediction file to be ready on S3. So that's how you can do loose coupling between different projects. Like that's called trigger based. So you have a trigger on another project being finished, and then I know that I depend on that to run. So you don't have to have a monster DAG. You can split things in several DAGs.
To that, just I think for both parts of the answer, do what logically makes most sense for your organization. So don't create a separate Docker container out of every single function you write. Just if you have one single project, try as much as possible, if it works, right, try to keep it in one Docker container. It's very simple to reason about. And the same with the DAGs. Like if you have one thing that delivers value to your organization, one defined data product, if you will, it is nice to have it in one DAG. It's not always possible to have one DAG, right? But the two extremes are bad. If you only have very small DAGs that all depend on each other, you lose overview. If you have your entire data platform in one giant Airflow DAG, nobody will be happy to manage that DAG either. So it's a bit where you can logically group things. They should be together in the same DAG. They should be together in the same container as much as possible. Yeah. All right. I think with that, we're at the end of the questions already. Yeah, so thanks all for joining. You know where to reach us. We'll send you the video link afterwards. You can still download the handouts if you want. It was a pleasure having you. I hope you enjoyed the 3-part series. If you did, leave a comment or something, tell us or share with other people like, hey, you should really watch the webinar. I hope this was helpful for your organization, for the work that you do. And I'm looking forward to seeing many of you in the hackathon. All right. Thanks.
Thanks, everyone. Have a great day.
Bye. You.